Hi, I'm Miss Lauren, and I'm from the Poplar Creek Library. And today I'm going to talk about some fun science experiments that you can do with your classroom or at home with your family. The first experiment I'm going to talk about is a simple circuit. A circuit is formed when a power source is connected to something that receives the current. So for this science experiment, what you need is some mini lights, a 9-volt battery, and wire cutters and wire strippers. So to get started, what you need to do is open up your lights. Now, I have already cut the end off of my light and removed the first light for this. But what you're going to do is you will start by cutting the light off. I'm going to cut just one off. And then you are going to strip the wire. So you're going to take the plastic part off of the wire. So the wire is exposed just like that. And then you're going to do the same thing on the other side. Okay. So both of your wires are showing. And let's go ahead and put these pieces aside. Okay. So to make a simple circuit, what you need to do is have a current traveling through to the power source and all the way through to the light bulb and back around. When both sides are not connected to the power source, forming a loop, then the current can't travel through. So what we're going to do is touch, we can see on the side of our battery, this is the negative side and this is the positive side of the battery. So we're going to touch the wire to one side and one side to the other side. Okay, so we're going to go ahead and do that. And we will see that our light becomes lit up. And we can see that it was very bright. So I've also cut some other ones. So this one has 2 lights on it. And we can see that if we touch it to the negative and the positive, it also lights up, but it's not as bright because the current is traveling just a little bit further. And we can continue on with that. I have 4 cut here. And again, it's not as bright because the current is traveling further. If we go back to just having 1, you can see that again, that it's very bright. Now, the reason why a current wouldn't continue to travel through is if the loop is broken, the circuit wouldn't work. If the loop continues to be connected to the power source, the current will travel through and the circuit will continue to work. The very longest one that I have here has 7 light bulbs. And you can see that while it does still work, the current has to travel a very far way and it's not as bright as it would be with just 1 or 2 light bulbs on it. But it does still work. This is something that you can do with your family or in your classroom. Let's see how many light bulbs you can get to light all together. And I look forward to seeing in the comments exactly how many you've gotten to work. Next, we will work on making some crystal trees. All right, so now we're going to talk about these fun crystal trees that I have in front of me. To make these crystal trees, we are going to need to measure quite a few things. So I have made some examples here of the crystal trees. It took me quite a few experiments to get them right. I made this one here first and then practiced on this one, and this was my last attempt. And I did them in all different conditions and with different kinds of cardboards. This very first one I did here at the library on my desk, and this one I did here in the hallway. And you will see later on a time-lapsed video of this tree, and it worked out the very best. And the cardboard I used for this one was the back of a notebook. So I think this one worked the best for me because it was used with the very thinnest cardboard. But to make this tree, what you need first is some cardboard. So here I have already gotten some cardboard and I've already cut a tree shape out of it. So all I did was use a Sharpie marker and I just cut a triangle out of it. And then you can just cut the tree shape on the sides. So I'm going to show you how I did that by doing this. You just cut the tree shape on the sides. You can go all down the sides like this. And you can use any tree shape that you would like to make. There's no right or wrong to make your tree. This is going to be your crystal tree, so it can look however you would like. This is just the shape that I'd like to use for my crystal tree. So you'll need 2 of these trees in order to make a crystal tree because it needs to be able to stand up. Let me go ahead and take these pieces out. Okay, so you see that I have a crystal tree and I have already made a crystal tree previous. Okay, so this one you can see I've cut a hole here in the bottom. Okay, so this one I'm going to cut a hole in the top so that they can stand up. So you just go ahead and cut a hole in the top. And go ahead and pull that out. And then they can go together. So to make sure it fits correctly. Okay. Okay, and then you can see that I've already painted with some green food coloring my one tree. So now I'm going to show you how I painted with green food coloring, and I'm going to go ahead and paint the second tree. Okay, let me go ahead and move these pieces to the side. Okay. So what I'm going to do is I'm going to use some green food dye. So that is one of the things that you will need is green food dye and a paintbrush. And you are going to go ahead and paint your tree. So you just go ahead and paint the tree with green food dye. Okay. I'm going to paint the whole tree with green food dye. And then you can set it aside while you work on mixing the other things together to make your crystal tree. So for the next step, you will need some sort of a dish. For this one, I am going to use a glass Pyrex dish. Then you are going to need some warm water. So I've already warmed my water up and it's here in this container. You will also need some ammonia. Okay, you're going to need grown up for this ammonia. I've already put ammonia in this cup here. You are also going to need some table salt. And you need some Mrs. Stewart's bluing. You also need a tablespoon and a spoon for mixing. So to start out, what you need is 4 tablespoons of table salt. So you can go ahead and measure 4 tablespoons. 1, 2, 3, 4. Then you will need 4 tablespoons of warm water. 1, 2, 3, 4. Next, you will need 4 tablespoons of bluing. Three and 4. And very last, you will need 2 tablespoons of ammonia. 1, 2. Okay, then you're going to mix everything together. And give it a good mix. Then you can assemble your tree and stand it up inside your solution, and you can wait, and overnight you will have a tree that looks like one of these.
The solution that we have mixed up has created a suspension, a mixture that has solid particles that are large enough for sedimentation or settling out. Our solid particles settled out on the cardboard tree due to a couple of processes. First, the liquid suspension is drawn up the cardboard tree through a process called capillary action. Capillary action is the ability of a liquid to defy gravity and flow upwards. In narrow areas, the combination of surface tension of water and the adhesive forces between the container of the liquid help to lift the liquid. This effect can be seen when a plant like celery draws up colored water through its capillaries, when paint is drawn up between the bristles of a paintbrush, and when porous materials like cardboard draw up water. The next process is evaporation, where liquid molecules escape from the solution as gas molecules. Ammonia evaporates much quicker than water, and we added it to the solution to speed up the evaporation process. Once the solution traveled up the cardboard and evaporated, the next process could occur. The final process, crystallization, occurred as the water and ammonia molecules leave the solution through evaporation. The bluing and salt that remain can no longer be supported in the remaining solution and begin to crystallize. Mrs. Stewart's bluing is a colloidal suspension of extremely minute particles of blue powder. These minute particles act as nuclei, or seeds for crystallization to take place. This is similar to the process that occurs in cloud formation.
Thank you so much for watching my video, and please don't forget to check out our books and online resources for more information. I hope you enjoyed, and we'll see you soon. Thank you. Bye-bye.